Okay, so how do you find the mean of a discrete random variable and also the standard deviation? So we did mean and standard deviation when it was like one set of data, just one list, right? Now we have a list of data and the probability that each of those takes, okay? So if you have a discrete random variable, which means it can be put in a table because there's gaps or spaces in between, then you find the mean. First of all, you need to know this symbol, so make sure you write this symbol down. It's like a cursive mu with a little x as the subscript. This x is your random variable that you should have defined at some point, or the book will define it for you. Like we talked about yesterday, the random variable was the number of heads that you got out of 3 coin tosses, okay? E of x is another way of saying mean. We call E of x the expected value. It still means the mean, okay? So you do need to know both of these symbols for the mean. And then how we calculate it is we do the data point times its probability plus the next data point times its probability plus the next data point times its probability until you get to the last one. I would write that formula down. So I'm just taking a little break here. Okay, this next one is what's on your formula sheet. Okay, and this says the sum of every data point times its probability. That's what's given to you on the AP exam. It will not tell you what this is for, so you need to know this is when you have a table with values and probabilities, which is called a discrete random variable. All right, but if you see those tables, you probably need to do this. So let's try one. So back to our APGAR scores, so like our random babies and the scores they get right after they're born. So compute the mean of the random variable x and interpret this value in context. So I want to find the mean, so I'm going to do mu of x. I'm also going to write e of x, just so you guys can practice that, because those mean the same thing. And I take the data point, which is 0, times its probability, 0.001, plus the next data point, which is 1, times its probability, 0.006, plus the next data point, which is 2, times its probability, which is 0.007. I'm getting tired of writing these, so you're allowed to do ... But then you still have to do the last one. So the last one is 10 times its probability, 0.053. Okay, so you are allowed to skip some, but you have to show the start of the formula like this. And then you can say what it equals, so you plug it all into your calculator and you get 8.128. What does this mean? Well, this is your typical APGAR score. It is a mean, it's an average. The really important thing when you interpret, you guys, and you might make note of this, when you interpret, you always say something about in the long run or after many, many babies, all right? Something about the long run or a lot of trials. That is my average APGAR score. Another really important thing, the AP graders will be mad if you round this to 8, okay? So do not round these answers. Okay, you lose points if you do that. There's no specific number to round to, like if you put 8.1 or 8.13, that's probably fine. All right, they don't have like in calculus, it has to be 3 decimal places, but you cannot round to an integer value on this. You have to show that it's a decimal. All right, so how they interpreted it, just to show you guys, the mean APGAR score of a randomly selected newborn is 8.128. This is the average APGAR score of many, many randomly chosen babies. Okay. There you go. Don't do an integer. All right, standard deviation. So how do we find the standard deviation? First of all, just remember what the standard deviation is It's how far it typically varies from the mean. So how far off are we typically from the mean? So our mean was 8.128. What's our typical distance from the mean? So remember that standard deviation and variance are friends. So if we start with the variance, we just square root our answer to get the standard deviation. So here's the formula for variance, and I would write this down. VAR, with your big X inside, that's variance, is equal to, this is sigma squared X. If it's squared, you know it's variance, okay? And the formula is the data point minus the mean squared times its probability. So you might want to fill in what those are. So that's your first data point. U of X is the mean. And then you're multiplying times P1. That's the probability that goes with that data point. Plus the next data point minus the mean squared times its probability, plus the next data point times minus its mean squared times its probability. Okay, this should look familiar. The only thing is, when we did this before and we only had one set of data, there was no p's in that formula. It was just the data point minus the mean squared plus the next data point minus the mean squared. That was how we calculated standard deviation. / our calculator helped us out as well. Okay. This is the formula on the yellow sheet that you will be given on the exam, which is the sum of every data point minus the mean squared times its probability. Again, this is the variance, okay? So when you want to find the standard deviation, you need to square root the variance. Notice this doesn't have a squared on it, so I have sigma x, and I square root that entire formula to find the standard deviation. All right, so same problem with our babies. Now we want to compute and interpret the standard deviation of the random variable x. So if you want to start with the standard deviation, then you would do a huge square root. Or if you start with the variance, you can square root at the end. I don't care, whichever way you want. But if you start with the variance, be sure you have a little squared right here, and then no square root, okay? So our formula is the data point, which is 0, minus the mean. Now the mean is what we just calculated in the last problem. So I have to always do that first if I'm finding the standard deviation. Squared. Don't forget that squared. A lot of people forget that. Times the probability, 0.001. That's what goes with the data point 0. All right, so that was that first one. Now I do the next data point, which is 1, minus the mean, 8.128, squared, times its probability, 0.006. Okay, now I can do my dot, 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 and now I'm going to try to squeeze this last one in right here. So I'm going to do 10 minus the mean, 8.128 squared, times its probability, 0.053. Plug it all into your calculator, and you get 1.437. Okay, it also says to interpret. Well, this is our typical distance that a randomly selected baby would be away from the mean, which was 8.128. All right, so we're typically going to vary by about 1.437 in our scores. All right. Okay, switching gears. All of that was discrete. Now we're going to talk about continuous. Continuous is actually easier, in my opinion. So what is a continuous random variable? It takes all values in an interval of numbers. There's no gaps or spaces, right? It takes all the values. The probability distribution X is described by a density curve. They will either give you a curve or tell you that it's normal, which means you can use the normal curve from chapter 2. The probability of any event is the area under the density curve and above the values of x that make up the event. So we just find the area under the curve when we're finding probabilities. So let's say they give you a curve that, well, it's not really a curve, but it is a density curve, I guess, that looks like this, right? It's uniform across the top. They tell us the height is 1 right here. And it says, find the probability that y is in between 0.3 and 0.7. So on the bottom, they shaded from 0.3 to 0.7, and the probability would be the area under the curve. So what's the distance from 0.3 to 0.7? Little subtraction, 0.4, right? And then this height right here is 1. Well, if it's a rectangle, it's just base times height. And so the probability of being in between 0.3 and 0.7 is 40%. Okay, so if it's uniform, it's like a good old-fashioned rectangle problem. Most of them will be normal curves. So back to chapter 2. So let's read this one. The heights of young women closely follow the normal distribution, where the mean is 64 inches and the standard deviation is 2.7. So I don't know if you guys remember this, but we're allowed to write capital N, where we put the mean, comma, the standard deviation. All right, that's just kind of organizing your data right there. This is a distribution for a large set of data. Now choose one young woman at random. We'll call her height Y. So they're defining Y as a random variable of a randomly chosen young woman. All right. If we repeat the random choice very many times, the distribution of values Y is the same normal distribution that describes the heights of all young women. Find the probability that the chosen woman is between 68 and 70 inches tall. So go ahead and draw the normal curve on your paper. A little review of the normal curve. All right, and we would title this guy height in inches for young women, and my mean is 64. And then remember, we add 2.7 right here. And I could add another 2.7. And I could add another 2.7, or I could subtract, right? Okay, and then we shade. I want to know the probability that some young woman, any random one that I pick, is in between 68 and 70 inches. Now, if you do this, these less than signs, or less than or equal to, it means the same thing on a continuous curve. There's no difference. Discrete matters because there's a break or a gap. But right here, you're going right up to 68 inches and right up to 70 inches, so it does not matter whether you have the bars or no bars. So now I'm going to shade 68 to 70. I'll just say it's like here-ish. And it's back to the normal curve. So we can use all our normal functions on our calculator. So hopefully you guys remember norm CDF. And your lower bound would be what? 68. And your upper bound would be what? And your mean would be 64. And your standard deviation would be 2.7. And you'd plug that in and you get 0.0562. So like 5.6% of women are between 68 and 70 inches tall. And if I choose a random one, that's the probability that I'm going to find one that's between 68 and 70 inches tall. Okay, so these should be fairly easy for you if you remember how to do them. Okay, so find, compute, and interpret the mean of x. I'm going to show you guys how to also do this on your calculator. So everybody grab a calculator. By the way, just in case you forgot, the formula is this times this plus this times this plus this times this plus this times this, right? Okay. Because you do have to know the formula. You always have to start it. Like you can do dot, dot, dot. So let's go to our calculator and go to your list and spreadsheets. And we're going to title this cars. And this is the number of cars sold on any given Friday. And it was 0, 1, 2, or 3. And the second one is your probability that that happens. So it's 0.3, 0.4, 0.2, 0.1. Okay, then go to a blank box. I always go back up to the top. It doesn't matter though. Go to any blank box. Go to menu. This is the same way you did it when we had one list. There's only one extra thing we're doing. And then go to stats. And then go to stat calculations. And this one variable statistics always tells us everything we know. It's still one variable statistics even though there's 2 columns, okay? Same as before. It's still number of list 1, which is kind of interesting. Don't change that to 2, it's just 1, all right? Here's where it's different. Last time we only had to put one thing in. For this part, your X list is whatever your variable is, which is cars, and your frequency list changes. We now plug in that probability for frequency list. And then press OK. The 2 things you need are the mean, 1.1, and notice S of X, that's usually what we use. It doesn't give us S of X, we use sigma X on this one. All right, sigma X for your standard deviation, which is 0.943. All right, so compute and interpret the mean of X. I would expect to probably see all the work on this, although I would still use your calculator. Also, be sure you say mu of X equals 0 times 0.3 plus 1 times 0.4 plus 2 times 0.2 plus 3 times 0.1. And that all equals 1.1. Now it says interpret. After many, many Fridays and cars sold, the average number of cars sold is 1.1. All right? And then you would do your standard deviation. So again, I would expect the formula to look like this: the square root of the data point minus the mean we just got squared times its probability, plus the next point minus the mean squared times its probability. And yes, I would fill that all out, but I'm being lazy. 0.943. Okay, what does that mean? We're typically off from our mean of 1.1 by 0.943 cars on any given Friday. Okay.